So hello everyone, this is Anurag Physics Tutorials, and today we are going to solve resistance cube problems. Okay, interesting ones. Now you can find lots of ways to solve the resistance cube problem, but I consider two things. The first is the simple one, and the second the most conceptual one, so that we know what stuff is going on here. So first of all, we are going to find along the body diagonal the net resistance of a resistance cube. So resistance cube basically means that there is a resistance in every side R, okay, equal resistances. So now the concept. So let us first give you the concept. The concept is find the symmetrical points. Find symmetrical points. Why? Because those points will have the same potential. So the points that are identical in all the respect should have same potential. Okay, and so we are going to find it by using a technique, and that technique is the way that we are going to solve the problem. So let us take any body diagonal. Let's take 2 and 6 extending from body. So let's take 2 and 6. Okay, so now the way to find the identical points is you take some path. For example, I have 2, I have 6. Okay, so if I have to go from 2 to 6, then there are 3 paths from which I can go from edge. So this path is edge, and this diagonal path is face part. Okay, so 2 to 8 it's edge. Okay, 2 to 8 it's edge, and from 8 to 6 it's face. Okay, similarly, if I take 1, if I go from 2 to 1 it's edge, and 1 to 6 it is face. So face. Similarly, if I take 2 to 3 and 3 to 6, it's again edge and face. So 3, edge and face. Are you getting what I'm doing? So repeat that thing for 6. So I'm going to repeat it. So I'm going from 5 via edge. So 5, and I'm returning to 2. So similarly from 4 and then return to 2 via face, and then from 7 and then return to 2 via face. Edge, 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 and face, face, face. That means that 813 will have the same potential, and 547 will have the same potential. So what I'm going to do is I'm going to now simplify the circuit. So I write here 2, I write here 6 at the last, and then I write a point in the middle, that is 8, 1, 3, because they have the same potential, and the potential is what we are concerned about. Okay, so 6, and then we have 5, 4, and 7. All right, so there are, now if you see carefully, then in between these 3 points there are 3 resistances. So let's make it quite good looking, 2 and 3, right? Okay, similarly, so let's do like this. Okay, similarly from 5, 4, 7 and 6 there are 3 resistances. So putting it there, 1, 2 and 3, and since there are 12 sides, so there should be 12 resistance. 6 we have already included there, 6 are remaining, and both are in between these 2 potentials. So this also should have same potential. So the remaining 6 will also have the same potential. So 1, 2, 3 and 4 and 5 and 6. Okay, these 6 also should have the same potential. So since all the resistance are of value R, then so this system will be R by 3, this system will be R by 6, and this system will be R by 3 again. Since these all are in series, so R net can be written as R by 3 plus R by 6, 2R by 3 plus R by 6, and it comes out to be 5R divided by 6. Okay, so this is the resistance for a resistance cube along a body diagonal. Quite simple. I hope you got the concept. Okay, this is the whole thing that we are doing here. We are searching some symmetrical points so that we can apply the rule of being parallel. Okay, thank you.